Well, let's go ahead and get started. And I think I know why my computer's running a little bit slower now. I should have rebooted my computer after my earlier class because I realized that I was running a virtual machine. I was running Linux, and I'm thinking that that's reason why it's going slower. Just guessing. Okay, so I'm gonna do a new game, and game object collisions. Save that. Okay. Now we'll go ahead and drop on a game object and create a 3D object and create a sphere and move it up. And I'm using my mouse wheel to move it back like that. If you have your camera selected, then you see your camera view right here. And if I had my move tool, see how you can move that around to get whatever view you want. If I grab the red, I can move it forward. So you got total control of the camera there. You also have a field of view here, such that I can change that and goes further away or comes closer. So if I were to run this, and you see it's right up there. So if you have trouble viewing something on your screen, then you can use that. Tinglet tools. Okay, that's about enough for the camera, I guess. I'm going to change the field view back a little bit. Okay, so now, like I said, if we ran this, it would just look like a sphere. What we want to do is we want to make the sphere behave according to natural forces. Gravity would make it fall. So if I click my sphere here, click Add Component, Rigid Body, and now if I run it, you see my sphere drops. Now, if I want my camera to follow my sphere anywhere it goes, then we need to change the position of the camera. So let's take a look at how to do that. For my sphere, again, when it changes, I want to change the camera. So I'm going to put the script on the sphere, not the camera. So I got my sphere selected here. I'll click the Add Component, choose New Script, and I'll just call this Movement. And what's going to change is since it's going to drop the Y. Remember, our camera's already pointing there, so it's already pointing in the correct position. But my Y is going to change. So I'm going to double-click this C# code. Camera is just a game object, just like anything else. So, since it's a game object, the camera has its own transform position that we can manipulate. So, for over my code here, if I get there, down here in the update, I'm going to declare a game object. I'll call it G camera. Then I'm going to do a game object. Dot find. Let's try it again. G camera equals game object. Dot find. And I'm going to put in the name of the object. Now, the name of object, if you click whichever object it is, you see the name over here. It says main space camera. Now, you don't have to leave it as main space camera. You can name this whatever you want. I could change this to the camera. So again, given whatever name you want. Then over here, I would type in the camera. This is what makes a connection between my definition, when I'm defining here, and the game object over here. Okay, so at this point, I can retrieve the position of it, which means I need to declare vector3 position, and I'll call it G camera position. So I'll say G camera or was it underscore? That's what I get for making it complex there. Position is equal to G camera dot transform dot position. Well, let's talk about what in the world this is doing. We already said this one makes a connection between our declaration of G camera and the game object. This gCamera.transform.position retrieves the X, Y, Z values that you see right here and assigns it to gCamera._position, this vector3 here. Now my Y is going to be changing. Well, I need to know the position of the ball, the sphere. So I'm going to have another variable here. I'll say sphere position. And I'll say sphere position is equal to this dot transform dot position. Again, you don't have to put the this there. I like that because it just really emphasizes that it's whatever object that this code is associated with. So instead of just saying transform position. Okay, now the sphere is changing. It's dropping in terms of Y values, which means I want to set the G camera position dot Y equals to the sphere position dot Y. Okay, it's all said and done. Then we want to So I was just thinking of some code. Once all said and done, we want to then assign that back to our camera. So I'm going to say my G camera. Actually, that was the G camera position. So I'm going to say G camera dot transform dot position is equal to G camera underscore position. Well, let's run that and see. It helps if I actually transfer it over. You don't have to leave it attached to Unity. That's if you're debugging. We haven't got to that point yet. Debugging's kind of handy. It's kind of looking better. And stop that. In the last class, I kept getting these weird error messages over in Visual Studio. Almost like I kept calling a process that didn't work. And not working now. My sphere's not moving, which means my code's bad. Boy, second bad code today. Let's see what I did wrong. Okay, so I set my set that for that's position of my camera. G camera, or that's my setting my game object, and then setting that sphere position is equal to this dot transform dot position. G camera dot position dot y. G camera dot transform dot position. Code got transferred over, appears, so it's not that. Where's my camera? The camera. That gets the current position of that. That's strange. I'm not resetting the sphere position at all. Which is fine because it should drop based upon gravity. Oh, never mind. It's probably working. We'll see if I put the terrain on there. Because as this is moving down, the camera should be moving down, and so it shouldn't look different. Potentially. Okay, let's drop on a terrain. So do a game object, 3D terrain. I'm going to move that a little bit. Position here for the terrain, I'm going to say is negative 20. That's Y. So keep that as 0. X should be negative 20. Z should be negative 20. Okay, I'm going to drop grass on it, so I'm going to right click on this. I have to go download some sand. Import. New asset. I don't think I have any. Just sand. Okay. And then I'll go to my terrain and do my paint, edit textures, add texture, and drop the grass on there. And click add. Okay, now let's try this. Okay. like I said, it was working. We just couldn't see it because there was no frame of reference with the ground. And now you can see as the ball went down, the camera went down. Okay, now we're going to do a little bit more than that. We're going to have the ball move on here. And as a result, the camera should also follow it. And then we're going to have some other objects in here kind of chase our character. So we'll modify that a little bit if you're in the previous class. Try to have a little bit difference in both of them, especially here first. Later on, they'll diverge just naturally. But come over here. I want to program in my camera or my sphere moving. See, this is where it can be become convoluted. Like you're not sure what in the world these different items are pertaining to. This is where maybe it makes sense to put them in separate pieces of code up here. In order to do that, you have to declare these items up here. Game object, G-camera. Vector 3 is G-camera. Position, sphere, position. Now I do not have to have these declared down here. These were declared locally, which means every time I ran this bit of code right here, which is every time there was a frame in your game, a game cycle, I ran this, it would redefine this the memory for these two, or these three, because there's three there. Maybe that's good, maybe that's bad. You have to really look at your particular instance in a game, and does it make sense to leave that memory assigned all the time? Does it make sense to just define it occasionally? If you got an occurrence occurs once in a blue moon, you don't want to define that memory at the very beginning of your game, because then it's consuming the memory throughout the game. You just want to define it briefly while you're using it, and then give the memory back. Up here is declared. It's not quite global, but you can think of it that way. It's declared globally, which means we can use it anywhere in the code down here. When you put it in here, it's declared locally. You can only use it within this code, which means up here in this initialize now, I could reference these items. But anyway, up here, maybe I want to say, and I'm going to try. I didn't try this in the previous class, but void move sphere. Can't spell. There we go. Okay, so I need to retrieve the sphere's position. There. I need to have, and that's, by the way, that's what I had down here. Sphere position. So now I can get rid of that. And I put my if statements here. If input dot get key, was it get key? Autofire, yeah. Key code dot left arrow. Then I'm going to say sphere position dot x is equal to sphere position dot x minus 0.5 f. If input dot get key. Again, I'd recommend typing this each time. You type it over and over, and it's going to become second nature. You want to sit there and wonder how do I do that? Just you're used to typing it. I'm going to increase it by 0.5. Now again, x is declared as a float, so that's why this 0.5 is a double, and I have to put an f under. That f converts it to a double for us. And if input.getKey.keyCode.up arrow, in the sphere position.z is equal to sphere underscore position.z plus 0.5f. If input dot get key code dot down arrow sphere, what do I call it? Sphere underscore position dot z is equal to sphere underscore position dot z minus 0.5f. Okay, finally, this dot transform dot position is equal to sphere underscore position. Now I'm a little bit leery of whether that's going to actually reference this dot transform dot position outside of the update, but we'll see. Now I need to call this, so I'm going to say move sphere. This is a method, and when it comes down here and does this update, it'll run across this and it'll say move sphere. Okay, so it comes up here and runs this code. This morning, I woke up. That's interesting. Why can I select anything in Notepad? I am in Notepad. Let me bring up a different one. Okay. This morning I woke up and I performed my morning routine. Now, my morning routine is pretty defined. I go in and do my business. Not going into any detail on that. Then I brush my teeth. I shave, shower, dress. Does not vary. My mind kicks in automatically. When my alarm clock goes off, I go and I perform these items. This is the idea of a method, is if you got lines of code that you're going to do over and over, and it's the same code, then you can put them into a routine, and then you can call this from anywhere. If I go out of town, I'm staying in a motel, same principle. When I wake up, my brain's going to call this morning routine, and I'll do these items right here. I go over and stay at my brother's house. I wake up, my brain will call this morning routine, and I do these items. Artificial intelligence is kind of taken off, and I've been claiming for quite a while that you can program a robot to think like a human. Maybe not my wife; she's kind of illogical at times. But for the most part, we're boring. We perform the same functions. You go get in your car, you got this set routine. So you can sit there and program all those different items. If I chose, if you're old enough, if I chose some kind of political event that occurred, based upon all of your past methods, all the steps you did, I could predict how you're gonna react. Now, maybe if you're young, then I couldn't predict that because there isn't enough of a history there to tell your reaction. And maybe when you're young, your opinions are not set, so you kind of maybe your actions this way this time, this way this time. But that's the idea, is you could sit there and program that. They're using artificial intelligence. I taught for a while for World Quant University. They offer a free master's degree in quantitative finance. And I did Python and statistics. You probably heard me say that already. But the part of their program is using machine learning. So have the machine learn these patterns of the stock market. And then based upon that, they'll be able to tell them what should they invest in. So it's changing. And I have no clue why that one won't close. Okay, so I call that. Now void. What void means is nothing's returned. It means I call it, nothing comes back to the main where it's called from. So when this gets done running, it just goes to the next line of code. Now you notice I got a beginning parentheses and closing parentheses. Inside would be what's called a parameter. When I went to the store 2 days ago and I asked my wife, I said, "Do you want me to pick up anything?" And she said, "I want you to pick up," well, she gave me a piece of paper because she figured I'd screw it up and get the wrong stuff. She gave me 2 boxes of Jiffy corn muffin mix or something like that. No, she said two boxes of Jiffy cornmeal. That was the parameters. She gave that to me, and I was supposed to go to the store and get that. Well, the parameters didn't match. There is no such thing as Jiffy cornmeal in a box. She meant Jiffy corn muffins in a box. So I had to call her and so forth. But that's a parameter. You're passing in, you're taking information with you. I was supposed to return something. I was supposed to return those boxes to her. I would not be void. If you looked at programming me, still nothing there. Okay, this one. I went, David went to the store. And she gave me a note that said, well, I won't even say note that said. I'll just say Jiffy cornmeal. Now, what I was supposed to return is I was supposed to return with the product. Like this right here. And this is idea of objects. You're returning some. And notice I made this real vague because another time she could ask me to return 2 pounds of hamburger, hamburger helper. This would change then. This is what she tells me to buy, and this is what's returned. So here, this is a void. And it doesn't have to be a void. It could be a double, it could be an integer, it could be a string. That's just whatever we're returning in the main program. Okay, enough about that. Then down here, see, that's the camera, that's the camera, that's the camera based upon the sphere. And this right here, what is this? This is the camera. Okay, all that's camera. So this right here should handle the sphere movement, which means I could have other code to handle the camera movement. So this one's called move sphere. Here I could have void move camera. Your blocks of code are in between a beginning curly bracket and a closing curly bracket. And I'm not going to retype all that. Move it. And then here I'd call move camera. You get rid of some of these lines, blank lines of code, and let's see if I screwed up where it doesn't work anymore. Probably. I'll go ahead and save. Always a good idea to save occasionally. I think it automatically saves in certain circumstances. But I couldn't tell you when. Maybe it's all the time. And did it come back? Okay. Okay, still working. Didn't break it. But if I move my ball, the camera isn't following it. So let's make those changes now. So I'll come over here, stop the debugging. Now, you're wondering, well, where do you make it at? Well, make it the move camera. That's why by putting this code into separate methods like this, you can organize your code, and then it's easier to think about. You don't need to wonder where do you need to put it. Now, as my X position and Z position change, different ways you could do this. I did this by accident in the last class, not on purpose. You set your camera position of X equal to the sphere of X. And you set your Z, which means that there's no lag on this. Where your ball is, where your sphere is where your camera is. It's kind of however you're developing your game on which makes more sense. Okay, let's wait till that looks like it finishes. Okay, so now I move my arrow keys. And you'll see it move that. Eventually, if I can find the edge, there's the edge. If I go off the edge, then I fly off and go down. So let's say I want to put walls up. Stop me from doing that. Oh, and by the way, to have a little bit of distance between the camera and the sphere, you change one of the components, maybe the Z component. You change it so it's further behind. Now I think this through myself. Okay, currently the camera's there. Camera's pointing at the ball. So the camera, the Z is negative 5.79. While the ball is 0. So if I subtract 3 from the ball, maybe 5, it'll work, in theory. So here, I said Z, didn't I? Okay, so minus 3F. In that case, the camera should still be pointing at the ball. We're going to see how to deal with the rotation later on. I have to refresh my own memory on the quaternarians. I'm saying that right? Okay, so then there's remove the ball. You see you got a back position. Now it could be based upon which way you're going in terms of the up down, left or right. Maybe you'd want to change the position of the camera. Like I say, I don't believe you can access these directly. Or maybe it's a 2D where I've tried it. Let's try that just for fun. So go in the other direction. I'd want my camera to rotate. Think about this. Okay, here, rotate it around there. Was that 180 degrees? Let's see. I'm following the. What's my camera doing? Camera for my rotation in terms of the X is 0. So if I add 180 degrees to it, or set it equal to 180, that'd be on the other side of the ball, in theory. Okay, so if up here I could declare a variable. And this will be my direction for my camera, which way it's pointing angle-wise. So I'm going to declare this as, I think I need to make it a float. And camera angle. Probably if I made it vector 3, it'd probably be best. But I'll start off with this, X. And so then down here, if I'm doing an up arrow, means I'm going away, I'm following it, so that should be 0. Now, this up arrow, when you do an if statement, I just have one line of code here. If you got multiple lines of code, you have to do a beginning curly bracket. Backspace. And you'll have to have a closing curly bracket. And here I'm going to set the camera angle X equal to 0 degrees. So camera angle X is equal to 0 degrees. And I'll make it a floating point. Now, if you're not familiar with trig, 0 degrees, here's your starting place, that's 0 degrees. You go all the way over there, that's 180 degrees. So if I'm facing this way, 180 degrees should be facing the opposite direction. So again, I'll put my curly brackets here. And I'll say my camera angle X is equal to 180 degrees. Not sure if this will work, but it'll be something we can try. That's a fun part about programming, I think, is to try it. Have some fun with it. Doesn't work, you take it out. Try something different. Now, moving our camera, this was based upon camera X. What am I changing with the up arrow and down arrow? I'm changing Z, aren't I? What do I call it? Camera X. Camera angle X, I mean. Let's change that to Z. Makes more sense. And I could, by default, I could up here, I could initialize it. Initializing it sets it equal to a beginning value. Okay, so come down here. Based upon which way it's going, then I'll either be behind or in front of the ball. So here, I'll say G camera. Position dot actually I want an if statement. If camera angle Z, now equals is how you check for equality, is equal to 0F. That means I want to be behind it. If my camera angle Z is equal to 180 degrees, I put an F there. Then I want to be on the other side. So I'll say G camera or underscore position dot Z is equal to sphere position dot Z plus 3F. Now that's all good. It'll change the position, but it won't change the rotation. I have to retrieve the rotation. And let's see if rotation's a vector. Camera rotation. Now here I've set the camera to G camera. So the question is, if I can say G camera rotation is equal to G camera dot transform dot rotation. And that's not promising, unless I spelled it wrong. G camera. Oh. Okay, it is a quaternary. I never can say that word. Okay, so I'm gonna take it out. It won't work. I have to research. It's not as easy as plugging in degrees, unfortunately. Okay. We'll play with that next time after I research how to convert from degrees to quaternarians. If I'm saying that right. Okay, get rid of that. Which one was I want to keep the minus. And get rid of those. Okay, so let me still check to see if it works. And if it does, then we're going to add other objects on here now that follow our character. Okay, so appears still be working. Our camera's following our ball. It's not going on the other side, but that's okay. Now the camera here, you can see your values. Rotation 0, about your Z. If you come over here, you change it to 90. Looks like that. Change it to 180. Looks like that. Rotation. Y was up and down. Z is Z this way. So rotating it like that is why it turns the world upside down. So sometimes it's useful when you're working with these to change the values right within the game and see what it does. I would want to rotate about the y-axis, and I think I'd want to do 180 degrees. And it's fantastic here. If I do 180 degrees, it does that. Of course, I'm on the wrong side of the ball now, so I need to change my Z to be something. Let's see what my ball is. Ball is 29. Camera is 26. So probably 32. Guessing. No. I got the camera. Position 32. How interesting. Doesn't let me change it to 32. But allowed me to change the rotation, but not the position. Oh, because my program's constantly setting it back. So over here in my code, even though I'm sitting there changing it, this is constantly setting it back on me. Okay, well, forget that. Okay, so now we're going to have our some objects chase the ball. At least one. Depends how time allows. So I'm going to drop another sphere on here. Do a game object, 3D object, and a sphere. And I'm going to move that over here. Part of the problem of not having to rotate in there is we won't be able to see it potentially if it's coming at us. Has a sphere collider already on it, so that's handled. And remember, ours has a rigid body. So we're going to have this come toward us. So you have to think about how you would accomplish that. And since Y we don't have to worry about, X and Z is the only thing that we really have to consider. So let's name this individual. Sphere 1, we'll call this bad guy. That's going to come toward us. So come over here. as you can imagine, maybe we want to come up with a new method here for bad guy. The position of the bad guy. You probably want to keep track of that. And camera's fine, so come down here. To move camera in place. Now I'm going to do avoid, move, bad guy. And don't want that. Then down here, I want to retrieve the position of the bad guy. This is where it's handy to actually start them with the same name. See how these are all different names? So now I have to come up here and remember it's bad guy underscore position. So come down here, bad guy underscore position equals to, and I need to retrieve the game object of that. Remember how we did the G camera? I'll say this will be the G for game object of bad guy. So come down here, G bad guy equals to game object dot find, and I named him bad guy. Remember I named him bad guy 1. Let's see. Nope, I named him bad guy. Remember this right here is a name associated with our game object. This find, it looks for any game object named bad guy. And this makes the assignment here. And so then when I retrieve the position of the bad guy, I'm going to refer to G bad guy, the game object, dot transform dot position. So then you have to decide how fast you want your character to go. Maybe I want to check if the bad guy position of the dot X is greater than the my sphere. I'm trying to think what I called it. Sphere position dot X. That means that in terms of the X values, the bad guy position dot the X component is greater than the sphere, which means I need to reduce the bad guy to get closer. So I'm going to say bad guy dot underscore position dot X is equal to bad guy underscore position dot X minus, and here's the speed of your individual. My ball is going at a speed of 0.5. So maybe I want this to go at a speed of 0.3. And we could do a similar type of thing. You can check if your bad guy position dot X is less than your sphere position dot X. That means that the X value of the bad guy is less than the X value of the sphere, which means I want to increase it. So bad guy position dot X equals bad guy position dot X plus 0.3F. Now let's leave it right there, and we're going to assign that back to the object. So we're going to say G bad guy dot transform dot position is equal to bad guy underscore position. Now I do have to call this move bad guy. I come down here and I say move bad guy. Is this about as confusing as mud, or is this making any sense at all?
Making perfect sense.
Making perfect sense to me.
Okay. Jacob, how is it? Am I going a little bit too fast, do you think? Jacobs there. I'm going to attach it to Unity. We'll build upon this, so don't think I'm gonna just jump into brand new stuff. You'll see me keep building upon this, adding maybe more bad guys and so forth. Okay, so now if I run this, in theory, it won't change the Z component to come after me, but we'll change the X. Well, that was fast. Now I need to go behind it so I can see it. Ooh, that's interesting. I hit it, went up. Now as I go to the right, see how it's going to the right? As I'm going to the left, it's going to the left. Now I'm a little bit fast. Oops, I went off the. That's curious. I was trying to get it to fall off the side of the map, but it doesn't look like it. Now, obviously, a camera that's not pointing down is not appropriate because with the camera being on this side and the ball being on this side, it's blocking it, so I can't see it. So my camera itself, I don't need to control this via code. I can just change it here. If I go to my camera, and the Y 2.38, change that to 5. Rotation, I have to really think this one through. Yeah, I guess I can just try it.
You would rotate down around X.
Okay. Yeah, I have trouble thinking that in terms of which way you're rotating. So now that should be better. Probably if I let's make that 7. And 30 still might be good. I could change the field of view if it isn't. That's interesting. Because in my code, I'm changing the Y component. I bet I am. Camera. Again, see, this is the beauty of it. I am. I'm changing the Y component right there. Now, if you're not sure if you're changing the right thing, you can comment out that line of code. What comment does normally documents, but it also allows you to keep that code there just in case you want to access it again. Maybe you're not sure if the one you're changing is correct. There we go. Now let's try it. Well, not quite. I don't have it pointed correct. But you see as I move it this way, that's moving to the right. As I move to the left, it's moving to the left. Now, what I really want to do is come toward me. And my camera is not pointing down enough. .45, that'll probably work.
It's not that it's not pointing down enough. It's that you have it too close to the ball.
You think changing my field of view? Like that?
That would do it. That would do it.
See, those are considerations you have to think about. Because if you change the angle, there it goes. If you change the angle, your ball will remain larger. But if you change your field of view, then your ball becomes smaller. Okay. Now let's have it chase me in the other direction. Because obviously that isn't too good for a game. So And it's very, very simple. That's most of the math. There isn't like real complex. You might think, well, don't we have to figure trig and figure out the angles? No, it's as simple as this. So I can say if bad guy position dot z is greater than sphere position dot z, then we're going to subtract it just like above. Bad guy position dot z is equal to bad guy. These variables that I've declared them is just horrendous. I'm having trouble keeping them apart, which means I've done a poor job of naming them. The idea is when you name a variable, it makes it easy for you to use, so you don't have to sit there and really think a lot on it. Either that or I just had too much fun over the weekend. There we go. So minus plus, greater than, less than. Everything says z. Okay. Okay, so now, oops. It'll never get me. I fell off. Interesting. I wonder why that will keep falling. Anyway, it's now chasing me. Now I want to put some walls on here to show the colliders on that, because I don't want it to fall off the side. So the walls are very just simply cubes. So I do a game object, 3D object, cube. And I can move it over here. Move it up a little bit. You can change the scale. Now you can change it manually like that, or you can come over here and see the scale says 30. You just change it to 40. So if you find it tedious sitting there moving that back and forth, then you can have total control over here. We had trouble in the previous class where our object was going too fast and went through the wall. Well, that's easy to correct with just the scale of the wall. I have to think about this. So z is this way. I think that's x. So for the x, I'd change that to 2. Or you could change it to 3. It makes it thicker. So the height of it was y, and I want that to be a little higher. And then we got our wall. It's got a box collider by default on here. And if I click the edit box collider here, this is where you could actually edit how big that is. For the most part, you wouldn't want to. If it's a box, you're going to see the box collider will match it up exactly. You don't want to change it. Now, if you got a different shape and you want to apply a box collider to it, then the edit actually makes sense. Okay, it doesn't look like I had to go far enough over. Let's see, that's 40, maybe 120. And the position, you really have to think in 3D on this. I want this scooted down. That's along the Z. 1, 5, 9, 20, 30, 40. That's probably good enough. Almost looks like part of it went down. We noticed that before where the terrain isn't exactly horizontal. I'm not sure why that is. If you look at the terrain here, Doesn't appear to be any kind of rotation on it or any kind of angle of any sort. But I guess the Earth is not necessarily flat anyway, so maybe they're accommodating for that. Okay, I got this wall here. Got this selected. You can duplicate this by right-clicking on it and choosing duplicate. You see another name here, Cube 1. You could call that whatever you want. And now if I choose the Move tool, I can move this over like that. You could right-click on this and say Duplicate, and then you got a new name, and then you could rotate. Let me think. 90 degrees? Or negative 90, I'm not sure which. About my Y, I believe.
90 around Y.
90 around Y, minus or positive, it
Right.
doesn't matter.
And throw that here. Yeah, see, I can move that out further this way, but I got this. I'm going to duplicate it. And then move it. And that's the thing about it, is that it's very easy to duplicate these. And then come up with different scenarios, and you could move this. And all of a sudden you have two parts to your playing field. Okay, so there's our camera to begin with. So now we're ready to run the game. Our character's going over here. Sure would be nice if I could remember how to rotate it. Whoa, that was interesting. How did he go on the other side? Ah, hit it and bounced. Of course, in a game, when the enemy touched you, the game would be over. You'd lose a life. We're going to see eventually how to do that. Our next step on that is going to be to put a rotation on it, so we can rotate and turn around, so we can see what's behind us and so forth, and then also how to handle collisions. Now, it's doing the collisions automatically, but what we're going to do is we're going to put in our code. So over here, we'll check for collisions. And if we have collisions, then we'll perform some kind of item. Could be you start the game over. Could be end your game. So there's a lot of different things you can do here. Is there any questions on any of that code there? Okay. Well, I want to talk about objects briefly. Because you see objects everywhere in programming. With objects, like there's my son likes this Legos, Star Wars Legos game. Must be 100 characters in it. Just like a ton of them. And so you got your Star Wars character, SWC, Star Wars character, abbreviated for that. And within the Star Wars character, they got certain decorations, movement. So they move roughly the same. Use your joystick, moves right, left, up, down, whatever the movement is. Now, you might say, well, no, they don't move the same. Some of them move faster, some move slower, some jump maybe a little bit more, some jump a little bit less. I think R2-D2 flies. So, yeah, that's true. But again, you have to think about it from a programming standpoint. We could put that if statement in to check for the key code in 100 different characters. So we've repeated that code 100 times. Well, instead of doing that, we're going to declare it one time, and maybe we'll pass in parameters that tell us a little bit about the movement. Maybe our parameters for the movement would be how fast it goes, so speed. Maybe it'd be, I don't even know. I haven't played the game for forever. But let's say speed then. So that R2-D2, who moves, is going to go slower than Jawa. A Jawa is going to go slower than who's a fast character in Star Wars? Boba Fett? I don't know. But that's how you'll program it. Now we declare that in a Star Wars character. Then down here, we create an instance of a Star Wars character. And maybe you give it a name. Maybe see R2-D2 is a new Star Wars character. Like that. And since we declared move them up above, maybe we're going to move, the movement probably isn't good, move. So assuming this is a method, maybe we're going to move R2-D2. And the speed of R2-D2 would be 2. So I've declared this up here with my object, with my class, and then when I call it, I pass in a parameter, and this is called different items here, but it's basically a parameter you're passing in, and that's going to cause them to move. Now maybe your Star Wars character, this is officially called a method. Maybe a Star Wars character is going to have a characteristic, a attribute, a property, and a name is one. Whatever you want to call it. Which means, down here, when I create a new instance of it, I can say R2-D2.name is equal to, probably a bad choice since I don't think he has a full name, or she. I don't know the gender. But that's where we give it an official name. Maybe his name's actually R2-D2 Smith. Now the difference here is that this does not have parentheses. So this is assigning a property, characteristic, attribute, and this is calling a method. Just like in our code here, where we called these methods. Now you might say, well, are those really methods? Yeah, they're a method of this class up here. So they are a method, but we didn't have to actually do our dot. All we had to do here was just call the method name, because it's assumed, since we're in this class, in this object, that we can just call it directly. We don't have to put the whatever name in front dot. I'm guessing you could do this. Yeah. You've been seeing me do this over and over, even though it says you don't need to do that. Because this is your object format. This is whatever you've named the instance. In this case, just this. It's pretty vague. And dot, and then we're calling a method, and then we're not passing any parameters in here. But you could. For example, instead of hard-coding the speed here, for the bad guy, I could pass in 0.3 F. That gives me an error here, because I'd have to come up here and say float speed. And then now, instead of hard-coding this, I put speed in here. Hard-coding's bad, by the way, what I've been doing here. But since we're just learning programming, I'm not worried about it. And now this is passing in as a parameter. So when this calls move bad guy, it'll assign speed to be equal to 0.3 floating point. So it'll be equal to 0.3, and then it'll automatically do that. The benefit of doing this is now, instead of being hard-coded in 4 places, maybe it's hard-coded in 20 places. Then I can just change it in one location, like I did to 0.6 there, and now my character, it's been updated in those 20 places. I don't have to change it all over the place. Even more than that, you could declare it up here as public, and then you can control that from within Unity. But we'll see more of that as time goes on.
Doing
hard coding, would it be more difficult than that to say add a status effect, like lower speed or something?
No, you have lots of different options there. So yeah, you could have a lower speed option, and I'm trying to think. In some cases in a game, maybe you want to lower speed or you want to raise speed, make it a little bit more entertaining. Okay, that's about all I wanted to introduce there. But let's talk about how that translates to this. All of these that I've worked with here are game objects. They inherit not a whole lot that they have in common. It looks like just this first transform is what they all have. Then they kind of vary into different items. Your cubes will all have the same, probably cube mesh filter. So when you ever do a cube, it inherits this from the object definition, the class definition of what a cube is. I don't see a whole lot of real depth in here that I can demonstrate. You know, like they don't have a 3D object that you have a polygon. Then within the polygon, you have a rectangle. And within the rectangle, you have a square. Each one of those inherits from the one above it if you have taken geometry. Polygon. Boy, it's been it's been 35 years since I've had geometry. Polygon was a multi sides, I'm guessing. Rectangle, it inherits all the different parts of a polygon. You say, well, what does it inherit? The perimeter, distance around. You know, that's still the concept is the same, though we calculate it differently. Get to rectangle, it's got four sides and they're 90 degrees. It gets to square. Square is a rectangle that has all the sides the same. So that's where you have multiple dimensions in there. And for the most part, I don't think you'll see probably a whole lot of hierarchy built in with this in that regard. Now, one last thing I want to show you is we dropped on a terrain here. I didn't raise any of it up, but I will next time, and I'll put some trees on there. But they have assets you can add. Some of these cost, but if you're sitting there looking and thinking, boy, it'd take me forever to create a terrain for this, well, they got terrain builders. And so you come out here and it'll build an entire terrain for you, build entire cities. So you don't have to sit there and spend a month building your game view or your game scene. Sorry. Some of these are better than others. You can pretty well guess the best ones are at the top. You know, it's how many ratings have got and so forth, unless everybody in their company did it. Here's 117 for river auto material. And so if you're trying to, and they give you So again, if you're trying to create a terrain, the tools may seem very simplistic what we have here, but they got assets you can bring in. And some of these are free, and I haven't played with them yet. Some of them are $5. Let me see how I get the free ones. Price. There. Which is the free ones? I started downloading one of these before class, but this is where if you're trying to create your own terrain, you don't have to spend a huge amount of time on it. You can choose one of these options. And when you choose it, there's different settings you can pick to control how many trees you're going to have, how many fog of war, how many hills maybe. But we'll get into the assets. Now the project that I want you to do here is I want you to just basically have one character you move and have the camera go with it, and I want you to have 2 objects to chase it. So just kind of duplicating the code we have twice. And so it looked very similar to what I gave you already. But you'd have move bad guy 1 and you'd have move bad guy 2. So this is just not to really give you something really hideous to work with, just to get used to programming this. Is there any questions on that? I'll go ahead and stop the recording.